Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework again tonight. We're looking in Math 1 at worksheet 9.1a. Remember, every problem in the homework help matches a problem on your homework. So if you're having a problem with a particular homework, go to that problem and we should be able to help you out. All right, let's get started. Our first problem shows us a rectangle that's 6 by 11 centimeters and asks us to find the perimeter and the area. You'll notice here that the these hash marks indicate that one hash mark means that this side here is the same length as this side here because they have one hash mark. On the other hand, these two have two hash marks, but it indicates that they're the same size, so this side is the same side as this side. So the hash marks indicate segments that are the same size. Now to find the perimeter, you remember that the perimeter is the distance around. Start at any point and walk around. How far do you walk? Okay, so in this case it's 6 plus 11 plus 6 plus 11, or 36 centimeters. Sometimes you may have learned a formula for the perimeter of a rectangle, which is the perimeter is 2 times the length and 2 times the width. So 2 times 6 plus 2 times 11, 12 plus 22. Again, it adds up to 34 as well. Now the area of a rectangle is simply the base times the height. That's how many square units fit in here. If we were putting in squares here, we would find there's 6 squares here and there's 11 squares this way. And if we fill it all in, you'd have 6 times 11 squares, or 66 squares. The area is 66, and in this case, it's centimeters squared. Notice that I'm multiplying 11 centimeters times 6 centimeters, so my units are centimeters squared. Whenever you're doing area, the units will always be a square unit, a square inch, a square foot, a square mile, etc. In problem 2, we're given a problem similar to 1, except for this time we're given the points. You notice these points E, F, G, and H, and we have to graph them, and then we end up graphing them, and then we find our thing. So I've already graphed them for you here. I graphed the points. Remember, you start at the origin. So for negative 3, 6, negative 3, the first one is always the x. The second one is the y. So I went negative 3x, and then I went up 6 to get to that point. And you do that for each of them. Remember, this is 6, 6. So I went over 6 and up 6. And then this is over 6 and up 2. Again, the x and the y, and the x and the y, which you should know from previous lessons. So once I connect the points, then I need to just figure out the lengths. Well, when I'm looking at this, I can just count them. Here I can count 1, 2, 3, 4. So that's the length of that one. Likewise over here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 4 on one side and 9 on another side. Or I can use for horizontal, I can use the exponents. So notice here, 6 minus 2, here 6 minus 2 equals 4, and gives me that title there. Likewise, if I go horizontal, I have the 6 and the minus 3. 6 minus 3 gives me 9 and gives me that length there. So if you do have a graph, you can count the squares, or you can subtract the x coordinates or the y coordinates to get the same thing. Once I have that, then to find the perimeter, I simply add up my sides again. 4 plus 9 plus 4 plus 9 is 26 units. Or again, I can do 2 times the length and 2 times the width, which is 8 plus 19, or 26 units again. Now, it didn't ask us for the area, but we could just as well do the area. Remember, area is simply the base times the height. So the area is 9 times 4, or 34 square units. Problem 3 asks us to find the area and the perimeter of a rectangle with a base of 5 feet and a height of 7 inches. So if I were to sketch that down here, I have 5 inches that way, but I have I have 7 inches high here, but then I have 5 feet wide. Now, the thing you got to be careful on this is to realize that we have feet and inches, and if we're going to do anything, we need to have them put the same. So what I'm going to do is, because the inches are smaller than feet, I'm going to convert the feet to inches first. So there's 12 inches in every foot, so 5 times 12 means that's 60 inches. So you notice here, this is the same as 60 inches. So I have 70 inches times 60 inches. So now to find the perimeter we add up the signs again. So 2 times 60, the length, and 2 times 70 is going to give me 120 plus 14, or 134 inches. Now, if somebody wanted to know how much this was in feet, what you'd have to do is you'd have to go, okay, 134 inches divided by 12 inches per foot, and you can see I get 11 with 2 left over. So the answer could be 11 feet 2 inches. Okay, so that would be the perimeter if they wanted to go back there. Now the area, same thing. Base times height, so 60 times 70 is going to be 420. Once again, if they wanted it in square feet, not square inches, we could divide that accordingly, although this time we would have to divide it by 12 times 12, because it's square inches, or 144. A little more difficult problem. Problem 4 asks us to find the area of the figure at the right, and all the angles it says are right angles. What I do is divide it into 3 rectangles. You can see the red is what I've added there. And I notice that since this is 9, and these are 3 and 3, 9 minus 3 minus 3 means at least 3 left over, so that leaves this being 3 as well. Now, by the way, I divided mine, drew horizontal lines. You could just as well have drawn vertical lines and done the problem that way too. We just want to divide it into rectangles because we know how to find the area of that. So first of all, I'm going to find the area of each of the rectangles I've created and then add them together. So my first rectangle here, 3 times 4, or 12 meters squared. The second one, notice I have 4 here, but here I have 3 and 3, so this is actually 6. So 4 times 6 is going to be 24 square meters. And then my last one is 9 times 4, 9 here and 4 up. So 9 times 4 is 36 meters squared. And so the total area, we just add them together. So 12 plus 24 plus 36, and our answer is 72 square meters. Problem 5 asks us to find the area of the shaded region. Notice that all the angles are right angles. And in this case, what we're going to do, our strategy is we're going to find the area of the large rectangle and the small angle, and then we'll just subtract the small area from the large area, and that'll give us the area of the shaded region. So the large one is simply 20 long by 10 long, or 200 square inches. The small one, you'll notice, is 6 by 6. If you look at these things here, this is 6 and this is 6. So 6 times 6 is 36 square inches. So we just subtract that from the 200, and we end up with 164 inches squared. Problem 6 presents us this problem. A rectangle has twice the area of a square. All right? The rectangle is 16 inches by 8 inches. What is the perimeter of the square? Be careful here that you know what you're asking for. To find the perimeter of the square, first we have to find the side of the square. So I notice first of all that the area of the square, the area of the rectangle is simply 16 by 8, or 72 inches. Now if that's twice the square, that means that rectangle, the area of the square, is half of the rectangle. In other words, 2 times the square is the rectangle, or the rectangle divided by 2 is the square. So I can take this area and divide it by 2, and now I know that my square has an area of 64 inches squared. However, the area of a square, since the sides are the same, is simply side times side, or side squared. So I know in this case that side squared has to equal 64. So if s squared equals 64, then the side is simply the square root of 64. Well, 64 is 8 times 8, so that means my side is 8 inches. But let's not stop there. We were asked to find the perimeter. So the perimeter is going to be the four sides of the triangle added up, 8 plus 8 plus 8 plus 8 plus 8, or you could say 4 times 8, or 32 inches is the perimeter of the square. Problem 7 kind of asks us to combine a couple things we've learned in this chapter to find the perimeter and area of an unusual figure here. So I've already marked the area, but here's what you would be doing. First thing I would do is divide it into a triangle and a rectangle. And you can see I've drawn that dotted line there to split a rectangle and a triangle. And then I mark the lengths. I mean, I simply count. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. And the only one I don't know is this one. I've included it here. But you have to remember, I'm going to get ready and show you how to solve that in just a second. So I can find 4 of the sides, and I need to find the next side. So we're going to use the Pythagorean theorem to find the hypotenuse. We have a triangle. It's a right triangle. So the hypotenuse there is going to be the square root of 3 squared plus 3 squared. There's my 3 and my 3. And so that's the square root of 9 plus 9 is the square root of 18. Simplify that more, I do my factor tree and find out the factors of 18 is 2 times 3 times 3. And notice I got 2 3's, so they're able to come out. The square root of 3 times 3 is 3, and I end up with 3 radical 2. Okay? Now that I have the sides, I can find the perimeter. The perimeter is going to be all the sides, add them up, 3 plus 4 plus 3 plus 4 plus 3 radical 2. So we have 14 plus 3 radical 2, and that's as far as we can go. And that's our answer for the perimeter. Now to find the area, we're going to find the area of the rectangle and the perimeter triangle and add them together. So the rectangle is easy. 3 times 4, 12. And our triangle is 1/2 the base times the height. You can almost see it here. If I had a figure here, 3 by 3, the triangle is half of that. So it's half of 9, or 4.5. So let's add them together. 12 plus 4.9, and our answer is 16.5 square units. Our last problem is a word problem. It says the perimeter of a square, that's the distance around. So the distance around the square is 80 meters. Find the area. Now remember, if it's a square, then every side is the same. That means the perimeter is s plus s plus s plus s, or 4s. So if I put in 80, if 80 equals 4s, let's divide both sides by 4. And that would tell us what the side of the triangle is. So the side of the triangle, 80 divided by 4 is going to be 20. So that's our side. Now what's the area? Well, the area is base times height, but since they're the same, it's just side times side, or side squared. So we have 20 squared, 20 times 20. So my area is 400 meters squared. All right, I hope that helped you. Hope you did well on your homework tonight.